We're doing a deep dive into 15 AWS EBS strategies. From systemsarchitect.io, every workload on EC2 depends on storage that's fast and durable. The gap between teams that get real value out of Amazon Elastic Block Store and teams that accept the defaults shows up on the monthly bill. It shows up again later in a painful recovery scramble. Amazon EBS gives you far more control than most people use. This video walks through 15 strategies for getting the most out of EBS, from picking the right volume type to securing data between EBS and EC2. 15 AWS EBS strategies. 1. Choose the right volume type. 2. Optimize cost with GP3 volumes. 3. Use EBS Snapshots for backup and DR. 4. Encrypt EBS Volumes for security. 5. Monitor performance and usage metrics. 6. Use multi-attach for high availability. 7. Optimize volume performance with elastic volumes. 8. Use EBS-Optimized Instances. 9. Automate volume management with tags. 10. Use RAID configurations for performance and redundancy. 11. Use lifecycle policies for cost optimization. 12. Plan for burst performance with GP2 volumes. 13. Integrate with AWS Backup for centralized management. 14. Test and validate snapshots for recovery. 15. Use VPC Endpoints for secure data transfer. 1. Choose the right volume type. EBS offers 4 distinct volume families for different jobs. General purpose SSD, GP3, and GP2 fit most everyday workloads. Provisioned IOPS SSD, IO1, and IO2 suit IO-intensive workloads like large databases. Throughput optimized HDD and cold HDD volumes cover sequential and rarely accessed data. Picking the wrong type either wastes money or throttles an application that needs more. Match the volume type to how the workload actually reads and writes data. 2. Optimize cost with GP3 volumes. GP3 decoupled performance from capacity, unlike its predecessor, GP2. With GP2, more IOPS meant buying more storage whether you needed it or not. With GP3, you provision IOPS and throughput independently of size. A baseline GP3 volume includes 3,000 IOPS and 125 megabytes per second free. Migrating from GP2 to GP3 can be done live with no downtime. 3. Use EBS Snapshots for backup and DR. Snapshots capture an incremental point-in-time copy of a volume's data in S3. Only the blocks that change since the last snapshot get stored. Data Lifecycle Manager automates scheduling, retention, and deletion. Sharing snapshots across accounts using AWS Resource Access Manager strengthens disaster recovery. Set retention based on your actual recovery point objective, not indefinitely by default. 4. Encrypt EBS Volumes for security. Encrypting EBS volumes protects data at rest using AWS Key Management Service, or KMS. Enabling encryption by default closes the gap where an unencrypted volume gets created by mistake. IAM policies control who can use a given KMS key. For regulated workloads, this combination often decides a compliance audit. We have a lot more about this on systemsarchitect.io. See the full section there. Also, make sure to like the video and subscribe to the channel for more, and check the video notes for links. 5. Monitor performance and usage metrics. You can't tune what you aren't measuring. CloudWatch gives EBS Volumes metrics for IOPS, throughput, and latency. Alarms notify you automatically before a user ever complains. Pair these metrics with EC2 level monitoring for the fuller picture. Set alarms on the metrics that matter most to each workload's SLA. 6. Use multi-attach for high availability. EBS multi-attach lets one IOPS volume attach to multiple EC2 instances at once. It's purpose-built for clustered applications that need shared block storage. The application layer, not EBS, coordinates writes and prevents corruption. All attached instances must sit in the same availability zone. Confirm the application actually supports concurrent multi-writer access before adopting it. 7. Optimize volume performance with elastic volumes. 7. Elastic volumes remove the need to plan size and performance perfectly on day one. You can resize, retype, or boost throughput without ever detaching the volume. That makes it realistic to start small and scale up as usage data comes in. It's also the mechanism behind live GP2 to GP3 migrations. AWS recommends waiting between modifications on the same volume. 8. Use EBS-Optimized Instances. EBS-Optimized Instances give dedicated network bandwidth between EC2 and EBS. Without it, storage I/O competes with the instance's general network traffic. Most current generation instances are EBS optimized by default already. This matters most for latency-sensitive, performance-intensive workloads. Pair it with a high-performance volume type like IO2 or GP3. 9. Automate volume management with tags. Tags attach metadata like environment, owner, and cost center to every volume. That metadata drives automation across Data Lifecycle Manager and AWS Backup. Consistent tagging makes it easy to spot orphan volumes and cost spikes. Enforce a small, mandatory tag set at creation, not backfilled later. 10. Use RAID configurations for performance and redundancy. Why reach for RAID at all? Striping volumes in RAID 0 can push throughput beyond a single volume's limit. RAID 1 mirrors data for extra redundancy beyond EBS's own replication. Both add real operational complexity, and RAID 0 actually raises failure risk. For most workloads, one correctly sized IO2 or GP3 volume is simpler and enough. 11. Use lifecycle policies for cost optimization. Old snapshots quietly pile up costs over time. The Snapshots archive tier can cut that storage cost by up to 75%. The trade-off is longer retrieval time, so it suits compliance retention, not fast recovery. Data Lifecycle Manager can automate the move once snapshots pass 90 days. 12. Plan for burst performance with GP2 volumes. GP2 volumes earn IOPS credits and can burst above baseline for short periods. What happens when that credit balance runs out? Performance drops straight back to baseline, which can look like a sudden slowdown. CloudWatch exposes the burst balance metric directly before it becomes a problem. For sustained, predictable workloads, GP3 is generally the better fit. 13. Integrate with AWS Backup for centralized management. AWS Backup centralizes snapshot policy instead of a patchwork of per-service tooling. One backup plan sets schedule, retention, and lifecycle rules consistently across every volume. It also supports cross-region and cross-account copies with an audit trail through Audit Manager. Standardize on AWS Backup as the single source of truth for backup policy. 14. Test and validate snapshots for recovery. 15. An untested snapshot is really just an assumption, not a working backup. Why does that matter? Restoring it periodically confirms the backup, not just the schedule, actually works. This kind of testing surfaces a bad KMS permission before it costs you a real recovery. Documenting recovery time also gives you a realistic recovery time objective to plan around. 15. Use VPC endpoints for secure data transfer. Traffic between EC2 and EBS normally rides the AWS network already. A gateway or interface VPC endpoint keeps that traffic off the public internet entirely. It can also reduce latency versus a NAT gateway or internet gateway. Combined with encryption, VPC endpoints round out a defense in-depth approach to protecting EBS data. In summary, these 15 strategies span the full lifecycle of managing Amazon EBS well. They run from choosing the right volume type and tuning cost with GP3 through encryption and monitoring. They also cover high availability options like multi-attach, backup, testing, and network security. No single strategy here matters in isolation. The real payoff comes from treating volume selection, cost, and disaster recovery as one ongoing discipline. Start with right-sizing and encrypting your volumes, then layer in automated backups and monitoring. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.